First presentation is an invited presentation entitled VTOL Aeromechanics from 1974 to 2024 and the Future, Advanced Vertical Flight. Presented by Kit Borden. Kit Borden works for the US Army, currently in PMO FARA. He has also supported FLORA program and comprehensive flight modeling of all of the existing Army rotorcraft fleet. He started working for the Army right after receiving his MS in aerospace engineering from Georgia Tech, and also has a BS in aerospace engineering from Arizona State. He has been on the Advanced Vertical Flight Technical Committee for over 10 years and has served as session chair and committee chair in the past. Unfortunately, Kit was not able to make it, so Carl Russell of NASA Ames Research Center, also Aeromechanics Technical Chair of this conference, will be presenting on behalf of Kit Borden. Carl?
Oh yeah, thanks for the introduction, Hyun-Soo. And yeah, for those of you who know Kit Borden, I am obviously not Kit Borden. But I'm going to do my best to present the charts that he prepared. He took the time to do them, and so I wanted to make sure that the kind of message in here gets said. Also, since, as Hyun-Soo mentioned, I am the technical chair of the conference, I am going to take the opportunity to thank the other presenters who did the invited history presentations. I don't know if it was a particularly welcome request that I sent to them, but I thought that they all did an outstanding job. And so I really appreciate Lauren and his team for doing the dynamics paper, Michael Strauss and Mark Scott for doing the aircraft design one, Wayne for doing the aero, and Natasha for doing the acoustics one. I thought they all did outstanding and really appreciate what they put together. Okay, so let's go ahead and we'll get started here. And I'm going to be talking about VTOL Aeromechanics from 1974 to 2024 in the future from the perspective of the Advanced Vertical Flight Technical Committee. When Kit let me know that he wasn't going to be able to make it, I started thinking of, well, who could do it? And I said, well, maybe you could talk to one of your Army colleagues. And it turns out that they need approval to be able to talk about things. So that led to, well, who else could I get to do it? And then I had that sinking feeling in my stomach when I realized that I had been the chair of the Advanced Vertical Flight Technical Committee at one point, and so that made me the most natural choice. So that's how we ended up where we are right now. So the theme of the talk is that advanced vertical flight requires advanced tools, and similar to a lot of the other history talks that have been presented, I'm going to go through some of the history of the Advanced Vertical Flight Technical Committee and talk about some of the technical disciplines that have been covered by this particular committee. So just kind of giving this quick history here. The Advanced Vertical Flight TC has not been around since the original Aeromechanics conference in 1974. It began in 2007, to my understanding. This was before I was working Rotorcraft, and so I'm going to trust that Kit got the right date here. But prior to that, there had been interest in multiple different technical disciplines that were not your traditional helicopter vertical flight. And if you for those of you who are kind of around for some of this development, you would recognize that what we're talking about there is stuff like the Joint Strike Fighter and other VTOL STOL aircraft. So the TC started in the mid-90s with special sessions on VTOL STOL aircraft. Then it got a new name. It got called Future Technology. In 2000, Advanced Vertical Flight Concepts, STOL Technology, STOL Powered Lift. Really couldn't settle on a name. And so again, 2003 we had unconventional VTOL aircraft design, and then getting into some of the DFS or AHS, probably actually American Helicopter Society at the time, sessions on VSTOL design concepts, STOL concepts, and then again in 2007, that's when it got called Advanced Vertical Flight. So what's in a name? So like I said, it started as the VSTOL and STOL, but the focus on that came into question because was the interest of this committee really only going to be the what eventually became the F-35? And so there was a bunch of discussion kind of around what the TC should be called. Apparently it was quite a vigorous debate, and eventually they settled on Advanced Vertical Flight, or AVF. And one of the primary elements of that debate was to make it clear that the TC had a very broad scope. And so there was an argument in favor of using the term unconventional, and basically with the idea being that, well, everything that the other TCs are doing is conventional, so this committee was going to do unconventional. But it was decided that, in the end, it was decided to go as advanced, at least in part because advanced sounds cool and unconventional sounds like the weirdos. And so they wanted to avoid that. And so there was an argument against using concepts as well, who felt that it was too restrictive, only a few vehicle configurations, rather than kind of the full gamut and associated technologies, tools, trendsetters for new vehicle types. So it started as the STOL group, inspired by the Joint Strike Fighter, but the purview of the committee kind of became the everything else of vertical lift. And then kind of one of the interesting things that came out of the Advanced Vertical Flight Committee is that some of the kind of new concepts that we see kind of start in this area, and then they graduate to other technical committees as they become more and more mainstream and no longer fall in that unconventional or advanced category. So there's been a range of topics that get covered here. I probably don't need to read all of them. And as when Michael was presenting on the dynamics history session the other day, he mentioned, if your favorite concept isn't here, apologies. These are the ones that kind of made it into the presentation. And again, some of them sound pretty not conventional, but getting to be more mainstream in terms of vertical lift. So obviously, the tilt rotor was one thing that kind of really a lot of the information that was getting published on, I guess, was in the Advanced Vertical Flight vertical lift, Advanced Vertical Flight special sessions. But then there's some other kind of a little bit more, I'll use the word unconventional because I don't think it's weird, I think it's cool. Starting to talk about things like cycloidal rotors, flapping wings, gyroplanes, then we have our compounds, and so those are maybe not quite so weird, but still pretty different from your normal helicopters. Still keeping the jet and fan lift, morphing rotors, human-powered helicopters. So back when I joined Vertical Lift, I think it was right around that time that the human-powered helicopter contest was starting off, and so we had a lot of discussion around human-powered helicopters. One of the cool concepts here was the second to last one on the right, the solar sail rotor. And so this was presented in 2014 from, it was in Forum 70. The paper was called Stability of Rotorcraft for Interplanetary Spaceflight. And the paper covered an analysis of solar sail design, and it was called a heligyro, that it spins and extends solar sail blades. It would then control its path by twisting the blades. So this was a pretty off-the-wall thing. To my knowledge, I'm not aware if this concept has gained any traction within any circles, but it was something that was presented in this Advanced Vertical Flight Committee. Just kind of, I think a few of the other history papers have talked about this, the number of papers that were getting presented in this area. And so kind of when it first started there in the mid-90s, there were really just a couple of papers that were getting presented in this kind of new session or new committee. And so, it wasn't until probably about 10 years ago, so right around the time of the 5th Decennial Aeromechanics Specialist Conference, that it was even getting up into double digits. But so the session at the forum has grown significantly. It does tend to waver a lot, and that's kind of something that I've definitely observed, just because it just depends on where the interest is and whether things are going into the more, quote-unquote conventional areas, as opposed to something that's really, really out there. Let's see, and then one of the things that I know Kit wanted to note here was that it has made it easier in the last few years as we kind of transfer things around and are able to put together really good technical programs. Okay, let's see. So we are on the right turn, 6 here, yeah. So again, this is the 6th Decennial Aeromechanics Specialist Conference here, and this committee wasn't around in 1974, but the topics that get covered here certainly are. It's not just a matter of the new concepts, but certainly there are a lot of the things like hub design and advanced aeromechanics that are true for a conventional helicopter end up being true for some of these advanced vertical flight aircraft. And so things that got included here are for example, the Cheyenne, the various tilt rotor designs, coaxial rotors, compounds, ducted rotors. We had a few things on flapping wings. I think one thing that got left off that list there is cycloidal rotors. We had a lot of those. And also non-conventional control schemes end up getting in here as well. So not just at the vehicle side, but at the kind of system and subsystem level. So talking about things like higher harmonic control, active blade control of many different varieties. Okay, so why is Advanced Vertical Flight interested in this particular aeromechanics specialist meeting? Advanced Vertical Flight is non-conventional because it's trying to accomplish something that traditional helicopters can't or can't do well or easily. And so as I mentioned on the previous chart, a lot of the fundamentals of aeromechanics go into making that happen. These things are built from the basic physics, and you're able to analyze and predict outside of your standard realm. So while we may have designed the tools to work on a standard helicopter, if you want to make it fly 200 knots in edgewise flight, you're still using a similar set of tools and similar set of concepts. It's just you're using a slightly different application. Again, to address concepts and configurations that are outside the realm of quote unquote typical. So Kit went and looked at, for the various specialist meetings from 1974 up through this current one, how many of the papers presented in the specialist meetings would be considered like advanced vertical flight related. Now, that doesn't mean that they would be specifically there, but it's the sort of thing that if it got submitted to the AVF committee, the committee would go ahead and take them. And so it's actually been fairly, it started out kind of low there in the first couple when the interest was more on conventional rotorcraft. But by the early 2000s, there was actually a fair amount of material being presented at this conference that would have fallen into this category of advanced vertical flight. He's got some paper topics and trends here, which I realize are actually a little bit difficult to read. And I think that just design tools. So Aerodynamics and design tools are those two spikes there on the right, I believe. And so those are kind of the main topics that have been covered within advanced vertical flight. So like I said, and there are probably 24 different topics there, but certainly a focus in a couple of them. All right, so again, kind of going through the decades in terms of, well, what were the trends and spikes in the technical areas. So obviously in 1974, the big interest was in rotor dynamics and doing model and test correlation. So you heard about that in both of the dynamics kind of history sessions, both that Michael was given at the beginning and that Bob and Dave were giving at the end. Moving into 1984, it was talking rotor dynamics, vibration, rotor airframe coupling, and so that, again, of course, that's going to become really important as you move into the higher speed aircraft, and you end up with a rotor and an airframe that are experiencing some pretty significant loads, together, and understanding how those loads are transmitted and interact with each other. And then, of course, doing model and test correlation. That doesn't really go away. It's always interesting for pretty much any application. And so those years really laid the analytical foundation for the tools that we're using today. So some of the trends, again, kind of moving along here as we get into the 90s. Again, we're still doing tool development. The tools are getting more advanced as essentially as computers get better and better and better. And once again, model and test correlation is constantly there as we are continually trying to do better and better. That continues as we go into the mid 2000s. These were kind of the topics that were there for the 2004 specialist meeting. Again, talking about tool development, talking about advanced aerodynamics. The tilt rotor was a larger topic of conversation there, and then also additional novel control schemes that were kind of coming online. So yeah, like I mentioned there, the spikes in these papers on tool development and especially comprehensive codes really comes with the explosion in computing power and availability. As I think Wayne mentioned during the aerodynamics talk, which was this morning, yesterday afternoon, the CFD didn't exist in 1974, and so as you moved into as coming into the future and computing power comes online, a lot of this tool development just coincides with the ability to actually use these tools, develop them, and have them produce something useful. So, the foundation that was mentioned on the previous chart of the scientific and mathematical basis really provided the ability to develop these tools that were then used as the computing power came online. Moving forward into 10 years ago, now we're talking about the very high fidelity CFD. And so again, we're talking tool development. We're talking about different novel configurations. At that point, there was starting to be a lot more interest in drones, and so we had a lot of interest in some of the really small configurations, and then in again, high fidelity CFD and aerodynamics. So CFD, CSD coupling was coming online. There was additional application of some of these powerful tools. And so some of the configurations that were being presented as part of that meeting were tilt rotors, compounds, coaxials, variable diameter rotors, and even flapping wings. And I don't remember if it was the 24 one or maybe it was the 2012 conference where we actually had somebody from, I think it was an AeroVironment that flew the Hummingbird around the room. So anybody who was in the room for that, you definitely can't forget that. That was a pretty good demo. Just kind of, again, going back, kind of taking another trip through time here, so these were some images that Kip pulled out from the dinner and general sessions that were presented in 1974. They look appropriate in a presentation today, and they look a little bit different than maybe you would expect. These were drawn for, I assume, overhead projectors and view graphs because PowerPoint obviously wasn't a thing in 1974. The information that's there is still relevant. We're still talking about impact loads. Bird strike is still very interesting to us. We're still talking about the flexible modes between, or flexible blades leading to coupled modes. We're still talking about flexible linkages and swash plates and the structural modes of both the airframe and the blades and pretty much everything else. And then I actually don't know what black boxes is referring to there underneath the person, if it's a recorder or some sort of model. So the basic problem here, though, is that, and this kind of goes back to a quote that I saw earlier in the presentation, and now I'm forgetting who had it, but basically that the ability to create the analysis kind of comes, is necessary to kind of make the original the original concept, the original idea come to reality. And so you have this crossing of concepts here. All right, so then in 1974, we had the comprehensive analysis coming online. This was really the major inflection point in the ability to do aeromechanical analysis. So we had multiple new tools presented, several of them listed here. Again, if your favorite isn't on there, you can talk to Kit about it because I didn't make these charts. But so the common set of UH-60A flight test data was completed to be used for the UH-60A airloads workshop, and then obviously that got completed later on with the wind tunnel test, which I believe is on a following chart here, and again coincides with the explosion in computing power. So a couple of additional additional papers here that recommended reading. So the supplements in the proceedings from the 1974 meeting. I believe this is what Bob was talking about the other day, which was the kind of the transcript. I understand that some of these are not exactly appropriate for a modern audience, so read with care. But supposedly there's some good information in there. I admit that I haven't actually read them myself. And then also in 2014 at the 5th Decennial Specialist Conference, there was a look back at the 1974 specialist meeting and the rotor loads comparison by Dr. Ormiston. Let's see, I just have, I think, 2 more charts here. So there's so one of the things that to mention here is that this meeting and the the various specialist meetings that are put on both by this chapter and the other chapters, and then obviously the VFS forum, are really important places for dissemination of information, but also they create the possibility of cross-pollination of our work with what others are what others are working on. And he, again, kind of brings up the solar sail heli gyro paper as an example of this is something that, maybe we wouldn't even think about, but maybe there's an actual kind of useful concept there that for those of us who are in the more traditional rotorcraft world would actually, stand to benefit from that. There's also a lot of benefit to using a standard problem. So there was the 1974 common problem, and then also the UH-60 Airloads workshop, which was a really good gathering of folks to work towards common problems and common understanding of the same data sets. So in conclusion, the tools changed, but the physics stay the same. Obviously, physics is pretty hard to escape. With better tools come the ability to take on harder problems, likely to require new solutions to these harder problems. The new possible solutions are the area of interest for the Advanced Vertical Flight Technical Committee. Obviously also there's I haven't said the word eVTOL yet, I don't think, in this presentation. And as most folks know, we now have an eVTOL Technical Committee, so a lot of these new configurations are actually kind of moving there. And so it's kind of an interesting thing. We go back to it was the first or second chart, and we talk about, well, particular concepts may graduate from advanced vertical flight into the more mainstream. I think of the different things that have kind of come into the Advanced Vertical Flight Committee or area and have then graduated, eVTOL might be the fastest one to get its own committee. That's just a reflection of the vast amount of interest that is there within eVTOL. So the last 50 years have brought us today's wonders. We're looking forward to another 50 more. I think Natasha said that she was going to be 86 years old at the 100-year anniversary. I'll be 90. That'll be interesting. So we'll see if I make it to that one. But yeah, so today's work really lays the foundation for what we work on in the future. So hopefully I did a decent job of presenting these charts. I know Kit wishes that he could have presented them in person. I do appreciate him putting them together. I'll do my best to answer any questions, but no promises that I'm going to be able to do a good job at it. Thank you. No, it's a great point, and there's been lots of work over the years of folks looking at planetary rotorcraft, and Larry's sitting here in the corner, and he's one who put together a lot of those kind of early ones, and it is really cool to see that these things that kind of showed up as advanced or unconventional and are now starting to become or have been real and successful missions, and it's just outstanding to see. Yeah. Yeah, and you actually made me think of another thing that I'll mention here is, so that was one good example of that when they flew that over everybody's heads, and I think a lot of people in the room probably went, wait, you're allowed to do that? There were multiple other presentations at forums, and they were in the Advanced Vertical Flight Committee mostly from I believe it was mobile students. So David Coleman and Hunter Denton doing their actual in-flight or flight demos in the conference room in those sessions, and those were always really cool because you're sitting there holding your breath the entire time, and David's sitting up here on his computer trying to make sure that the right software is uploaded or that the thing is going to work, and they had some kind of seat of the pants flight tests. They probably weren't as seat of the pants as maybe I thought they were, not knowing exactly what was going on, but those demos were always really fun to watch, and fortunately those are things that you can do when your aircraft is only this big. I would say, in the time that I spent with the committee, so I was on that committee for several years, probably at least 5 years, and the vast majority, I would say, certainly the vast majority of the small concepts were coming from universities. We did have stuff in there that was also from industry. We, sometimes, again, because compounds and tilt rotors, a lot of times would get presented in that group. We would have stuff like that from industry. So we would get, Airbus or probably Eurocopter at the time, and we had stuff on the 609 from Augusta. Yeah, that would be on the larger hardware side, and then on the smaller hardware side, it was almost exclusively university work, and then a little bit from government. Yeah, I would say pretty university heavy though. Yeah.
Thanks a lot.
All right.